Hello, everyone, and welcome to our 10th lecture in our course on general psychology. And this lecture is going to begin a new unit, and that unit is about learning. So we'll spend the next two lectures talking about learning, and then we're going to start talking about memory. And these are obviously related processes. It's hard to talk about one without referring to the other. But this unit, we're going to talk more about the psychological level of learning. We're going to talk some about the brain as well, but we're going to be talking about simple forms of learning. And this is going to be a trend we see as we get further into the course, that we'll talk about things at a more psychological level. We've covered the brain, we've now covered the senses, and so now we'll start talking more about the processes that we think about when it comes to psychology. So what we're going to do in this unit, in particular, is talk about conditioning, which is a particular kind of learning. Not all kinds of learning fall under the umbrella term of conditioning, but several do. And so it's a simpler form of learning that we'll talk about today. So one example is classical conditioning, which you may have heard of. If you've heard of Pavlov's dog, that is an example of classical conditioning. So that's the first major form of learning that we'll talk about in this lecture. There's also operant conditioning, which we'll talk about today as well. And operant conditioning is a form of learning in which the organism's own behavior drives learning. In classical conditioning, the learner is sort of passive. They're receiving information from the environment, but don't really have to do anything to learn. In operant conditioning, the organism has to do something. We'll talk about the influences on conditioning. What changes how easily the animal is conditioned, or how quickly, or what makes conditioning go away. How can we unlearn things? So we'll talk about those influences. And we'll also go back to the brain and learn about conditioning's relationship with the brain. What parts of the brain are relevant to conditioning? So what we're going to do today are first define our terms, give some examples. We're going to understand what classical conditioning and operant conditioning are. So what do these things mean? What differentiates them? What factors are relevant when we're understanding this form of conditioning? We'll also understand the importance of outcomes. So when we learn something, we affect our future behavior somehow. And the outcomes we experience as we learn are a very important part of that equation. So how do those outcomes matter? Is it a reward? Is it a punishment? How does the timing matter? And so these things all affect how quickly we learn and unlearn whatever it is we're being conditioned on. We'll also see what regions of the brain are important for each type of conditioning. And depending on the form of conditioning you're using, different brain regions are important. If you remove part of the brain, then you may lose the ability to be conditioned in one sense, but still retain it in another sense. So first, what is learning? Well, your book uses a definition that I think is pretty good, and it is the acquisition of new information, skills, or behaviors. So that's fairly understandable. Fits well with our intuitive notion of what learning is. Your book also incorporates the idea of it being from experience. And certainly when we're talking about conditioning, that's true. And that'll be our main focus today. When we get to our next lecture, we'll see that not all learning comes from direct experience. So we have to qualify this a little bit. So some forms of learning occur by observing others. We call that observational learning. Some forms of learning occur in the classroom. We'll talk about that as well. So there, you're not learning about the world through direct experience, but you obviously are learning something, hopefully. So we want to avoid the idea that all learning comes from direct personal experience. You have to experience some sort of stimulus, even in the classroom. You may read something or you may listen to something. And so that is an experience of a sort, but it may not be an experience that directly relates to the phenomenon of interest. Anyway, for the most part, and certainly for today, learning involves experience. Your book also uses the term relatively permanent change. Well, that's a little bit vague. What is relatively permanent? Well, it's usually long term. And so if you learn something, but you only know it for a second, it only affects your behavior for a very short amount of time, it's questionable whether we would call that learning. There certainly are short-term forms of learning, but we're talking about changing the nervous system somehow so that it produces one behavior and not the other. And of course, many things that we learn, we retain for decades or our entire lives. So those are very permanent changes in our nervous systems that give rise to different behaviors. Um, the question is how permanent does it have to be? And as we'll see, there are certainly ways to unlearn something when it stops being useful. So it doesn't have to be absolutely permanent, but it does need to be stored in the brain, in the nervous system somehow. We're not going to talk about this very much in this lecture, in fact at all, but there are simple forms of learning, and your book mentions those as well. These are actually not forms of conditioning. These are what are called non-associative learning. And what that means is that when we get to conditioning and other forms of learning, uh, those forms are associative. You're learning about the connection between one event in the environment and some other event. Or you're learning about the connection between your own behavior and some outcome that you want. Or you're learning about what someone else did and what they experienced. But you have two different events, a behavior and an outcome, or one event in the environment and another event in the environment. Non-associative learning, you're only dealing with one thing. That's why it's non-associative. You're not associating two things. You just have to worry about one. So for example, habituation. If you have a stimulus that occurs repeatedly, uh, you will habituate to it. It no longer becomes as noticeable. You are no longer as likely to respond to it. And so your book gives the example of being in an environment with noise. And certainly we habituate to noise. If there's a regular noise, even if it's a loud noise, at first it grabs our attention. But after a while, we get used to it. We habituate. So we no longer respond to the exact same stimulus because we've experienced it over and over again. And again, we're just dealing with one kind of stimulus here. That's why it's non-associative. In this sea slug called a plesia, uh, you get habituation as well. This is a very simple organism, but it still exhibits habituation. And the way it does it is this organism has a gill that sort of sticks out of its back, and it's very sensitive. It doesn't want it to get damaged. And if something touches it, the gill can withdraw. It can pull into the body of the sea slug. But if you touch it over and over again, if you touch the siphon, which is part of the organism's body, over time that gill will withdraw less and less, and then not at all, because the organism is not being harmed. And so it gradually learns to ignore that stimulus because it's not important. It's not suffering any damage, so might as well just leave that gill out there. Your book also uses an example in our culture of things like violence in movies and the trend over not seconds or minutes in the case of aplesia. Here it's over decades. So why is our society and individuals in our culture, why is our entertainment more violent, arguably, than it used to be? And whether that argument is valid or not, the question still remains, how do we get habituated to these more abstract concepts like violence in the long term? But certainly if we're inundated with a stimulus like violent material, then we no longer respond as strongly to it anymore. And of course, if we want to experience the same response, we need to increase the impact of the stimulus. We need to make it stronger. In this case, we need to increase the violent content. And so that's the question your book asks. Why has entertainment gotten more violent over the decades? So there's habituation. There's also the opposite, sensitization. And again, we're dealing with one kind of stimulus. It's still non-associative learning. And here, this is where the opposite happens, where the individual becomes more sensitive. You get a bigger response to the same stimulus. Usually because some sort of damage or harm has occurred. And so associating that stimulus with an internal experience of pain or harm can sensitize the individual or the organism to that stimulus. So now you get a bigger response. In the case of aplesia, you get a bigger withdrawal of that gill. So that's another form of non-associative learning. Moving on to associative learning, where you're connecting events in the environment, or connecting behaviors to outcomes, that's what's going to occupy us for the rest of this unit. So you have, for example, classical conditioning. So there, the organism associates one stimulus in the environment with another stimulus. There's also operant conditioning, where the animal learns to associate a behavior with an outcome, a reward or a punishment. There's also observational learning. You're associating a behavior, this time not your own, but someone else's, with some sort of outcome. And we'll also learn about implicit learning. And this is where you learn things without even being aware of them. So this is often in the domain of skill learning, but doesn't have to be. And here you learn what behavior to exhibit based on outcomes, but you're often not aware of why that behavior is the correct one, or that even that you're getting better at it. So those are all forms of associative learning. Okay, to begin our lecture here on conditioning, we'll start by talking about classical conditioning. And it's hard to talk about classical conditioning without talking about Pavlov's dog. So Ivan Pavlov was a Russian physiologist, lived in the late 19th, early 20th century. And he actually wasn't interested initially in psychology. He wasn't interested in classical conditioning. He was interested in something else entirely, the salivary, the digestive behavior of dogs. And this he just sort of knows is a side effect. But what he saw was a pairing between a stimulus and a response. And that is conditioning in its simplest form. In this case, of course, the story is that Pavlov had these dogs that he was feeding, and they would salivate in response to the food being presented. Well, that's not all that surprising. You even mentioned food, and people's mouths will water. We have that expression in our language. But certainly, if you present an animal with food, they'll start to salivate. So Pavlov didn't have to teach the dog to do that. The dog did that anyway. What Pavlov's discovery was if the bell that he rang preceded the food or was associated with it in some way, you have this previously neutral stimulus, which is a bell. Normally, the dog doesn't respond to a bell at all. It has no reason to. It's not a particularly loud bell. And they certainly don't respond to a bell by salivating. So you have this neutral stimulus, but you also have this other stimulus. You have two stimuli. And that other stimulus is food. So Pavlov rang the bell, but also presented food. And of course, the dog responded by salivating. And Pavlov could measure this with his equipment, how much the dog was salivating. And that was the response, salivation by the dog. And again, the dog would usually salivate when presented with food. So that's not the surprising part. The surprising part was after a while, the dog would salivate in response to the bell, even if the food wasn't there. So that's the classic example of classical conditioning. So after that discovery, Pavlov continued to work with this phenomenon and started to understand it a little better. And there are some terms that we need to know when we're talking about classical conditioning. And a classical conditioning task or setup has four basic elements. It has what's called the unconditioned stimulus. In this case, we're talking about food for Pavlov's dog. And this is the stimulus that's the environment. It's not what the dog is doing, it's a stimulus. So the environment has the stimulus, but the dog doesn't have to learn anything to respond to it. So again, Pavlov did not train the dog to salivate in response to food. The dog would do that anyway. So that's why the food is the unconditioned stimulus. There's no learning required for that one. You also have the unconditioned response, and that is salivation. So the dog salivates in response to the food. Again, no learning required here. Unconditioned. So these things occur before any part of the conditioning experiment has started. So the dog normally salivates when food is presented. But then you have the conditioned stimulus. Now normally that bell is a neutral. It doesn't produce any kind of response by the dog. And without the food, at the beginning, that's exactly what happened. You could ring the bell all you wanted, and the dog wouldn't really respond to it, at least wouldn't salivate. But then there's what's called the acquisition phase. And so this is the key part of the conditioning process. So what Pavlov did, of course, was ring the bell at the same time that food was presented. So now you have a pairing of these two events in the environment. And that's what classical conditioning is about. It's about understanding the connection between events out in the world. So the conditioned stimulus is the bell, because after learning, the dog now responds to the bell. And the conditioned response is salivation in response to the bell, after the bell is rung. And you'll see that these things are often referred to by their initials, US, UR, CS, CR. And it might be a little bit confusing because the unconditioned response and the conditioned response seem like the same thing. They're both salivation. And behaviorally, they are the same thing. That's right. The difference between the UR and the CR is that the conditioned response is what happens in response to the conditioned stimulus. So the behaviors may look the same, but it's what they're responding to that's different. So in this case, the conditioned stimulus is the bell. It was neutral before. Now it is associated with a response because it's associated with the unconditioned stimulus. The conditioned response is salivation, in particular, salivation in response to the bell. And so now that the dog has learned this pairing between the bell and food, between the conditioned and unconditioned stimulus, it now exhibits the conditioned response after the bell alone. So now all you need is the conditioned stimulus, and you will get the conditioned response. Okay, so that's how we get classical conditioning. We pair a neutral stimulus with the unconditioned stimulus, and we end up getting the conditioned response. So the organism learns to associate that neutral stimulus with the unconditioned one that it responds to normally anyway. But that doesn't have to be permanent. Conditioning can last for a long time, including up to years or the organism's lifetime, but it can also be unlearned. And that's a process we call extinction. So extinction is the gradual elimination of that conditioned response. And the way that it's done is first, of course, you have to acquire the conditioning. So that is the acquisition period that I've highlighted here. You pair the CS and the US over and over again. And so the organism learns the conditioning. So it is now conditioned to associate the two. However, if you start delivering the CS, the conditioned stimulus, without the US, the unconditioned stimulus, then the animal will eventually learn not to associate the two. It will unlearn the conditioning. So that's what extinction is. And this is what Pavlov did, so that the dogs would unlearn the pairing between the bell and the food. He started delivering the bell without the food, and eventually the dog stopped salivating in response to the bell. However, there was a question in Pavlov's mind whether the pairing was totally unlearned, so the CR, the conditioned response, had gone away. So it looked like the animal had forgotten it. But Pavlov wondered if the animal had really totally forgotten that pairing. And it turns out that no, some residual knowledge still remained. So the animals exhibited what is called spontaneous recovery. And this is after a delay. So after extinction, after Pavlov had given the bell without the food, waited a little while, and then rang the bell again. And the dog would still salivate a little bit. Not quite as much, but a little bit. And so clearly some of that knowledge was still in there, so to speak. The dog had not totally forgotten the pairing between the bell and the food. And again, this did not require additional pairings of the bell and the food. If those were given, certainly the dog would relearn it and would exhibit the response again. But the fact is that Pavlov could give just the bell as long as he waited a little bit after extinction, and the dog would salivate a little bit again. And then, of course, you could keep on delivering the bell without the food. You'd get extinction again, and you could have a second spontaneous recovery where you wait a little bit, you ring the bell, and then you get a little bit of salivation. You get a little bit of that conditioned response still. So that knowledge was clearly still there somewhere, even if the dog stopped exhibiting the conditioned response. And there are a couple of later things that we learned about conditioning, a couple of general principles that are important when we apply conditioning, especially when it comes to things like animal training. One of them is generalization, and that is the idea that the conditioned stimulus, the bell in Pavlov's case, uh, does not have to be exactly the same to still get that conditioned response. So the bell could look a little bit different or sound a little bit different, uh, and you could still get that conditioned response, still get that salivation, to use Pavlov's example. It wouldn't be quite as strong a response, and the more dissimilar, the less like the original bell, the new conditioned stimulus was, the less response you would get. But still, it was not the case that you had to have the exact same conditioned stimulus every time or the dog would do nothing. Uh, so that's what we call generalization, the ability for the organism to sort of extrapolate, to respond to a little wider range of stimuli than just the literal CS it was originally given. But there's also the counterpoint, discrimination. So as I've already said, the response isn't as strong for less similar stimuli. So clearly the dogs were able to tell the difference and respond not quite as strongly. So they didn't generalize totally. They didn't treat every bell-like stimulus like it was the same. They could still discriminate to a certain degree. And so that's that flip side of that coin. They generalize, they respond generally to that kind of stimulus, but not quite as strongly. It can still clearly tell the difference. And there are a lot of examples of conditioning that we can think of. Certainly animal training is one that pops to mind. So a trainer might try to get a certain behavior from a dog. And of course, the trainer wants to reward the dog for good behaviors to get the behavior in the first place. But perhaps the trainer doesn't want to, you have to use a treat every time. And so what many trainers will do is pair a neutral stimulus, like a little click sound, with either a reward or a punishment. And after a few pairings, the dog will actually start responding to the click by itself and no longer needs the treat or the punishment to use the click as a signal that it's given a good or a bad behavior. So animal training conditioning is used a lot. In humans, there's the case of little Albert, which is the sort of experiment that would never be allowed today. But it's something that John Watson did because Watson was interested, was curious whether this sort of conditioning could be applied to humans, especially humans in the context of more complex behaviors. So things like bells and food and salivation are all pretty simple stimuli and responses. Watson wondered if it could be more complex than that, and indeed it could. So he got an infant, an otherwise normal infant, whose sort of code name, at least for the purposes of publishing the results, was Little Albert. And so Little Albert at first didn't have any real response to a variety of masks, to animals such as a white rat or a white rabbit. And then what Watson did was condition Little Albert. And so every time that Little Albert reached out to pet the white rat, Watson would hit a metal bar with a hammer. This is a very loud, unpleasant sound, and not surprisingly, Little Albert would start to cry. And as Little Albert repeatedly reached out for that white rat, Watson would deliver that noise, the unconditioned stimulus, again. And soon Little Albert learned not to touch the white rat. And in fact, he exhibited generalization. He was also not only afraid of the white rat, he was also afraid of things like the white rabbit, things that looked similar, things that were white and fluffy. And so we see a little bit of that generalization even in humans. And we also see conditioning in a more complex case, reaching out to touch a white rat versus something like a bell. And so little Albert and humans in general can be conditioned. And we see this in things like advertising, where advertisements will have the product they're trying to sell, but also have some other pleasant stimulus. Maybe it's a popular song. Maybe it's an appetizing looking drink. Maybe it's an attractive model showing off the product. And so the idea is that we with repeated viewings of the commercial, we become conditioned to associate the product, which was previously neutral, with those pleasant stimuli, with whatever feeling we get when we hear that popular song or witness those other stimuli. So advertisements depend on this quite a bit, and it turns out actually to be effective, which is why they do it. And then finally, this is also used in the field of medicine. And so, especially in chemotherapy, where one of the side effects of chemotherapy, cancer treatment, is nausea. So you're given these chemotherapy drugs, and they often make you lose your appetite or make you downright nauseous. And one of the dangers there is that if you've just eaten, that unconsciously you may associate that nausea with the food you've just eaten. Now, consciously you know it's the chemotherapy, but you can't help it. Especially when it comes to foods and things like nausea, we're very quick to learn pairings between foods and nausea, and we can lose our appetite for those foods. And so in order to avoid that, especially if you're undergoing cancer treatment, you want to keep your appetite up. What doctors will often do is give an odd flavor of candy, something like pumpkin candy, uh, to go with the chemo. And that way, the person associates the nausea from chemo not with the meal they like, but with this odd flavor of candy. And so if they lose their appetite for that particular kind of candy, that's not a huge loss for the person. Whereas if they lose their appetite for foods they usually love, that is not just unpleasant, it's also bad for their health in the long run if they lose their appetite. So that's one more way in which conditioning occurs in humans. Okay, so that's classical conditioning. And that told us a lot about how animals learn the connection between events in the environment. So the conditioned stimulus and the unconditioned stimulus. But these are all things that happen out in the environment. They don't depend on uh, the animal's response. In Pavlov's case, the bell was paired with the food. Whether the animal salivated a lot or a little didn't impact what happened next. But that brings us to operant conditioning, which is a different form of learning. And this is learning in which the organism's behavior matters. It affects the future. It affects what the animal learns. And specifically, it means that the consequences of current behavior affect future behavior. So current behavior produces some result. The animal learns the connection between the behavior and the result, and then alters their behavior in the future depending on whether or not they want that result to happen again. And one of the first people to study this phenomenon was Edward Thorndike. And what Edward Thorndike did was he designed a puzzle box, which was really just a cage with a door and a lever in it. And he'd place a cat in this box. And at first, the cat would do all sorts of things. It would vocalize, it would make noise, it would walk around, it would sit down, it would scratch at the bars, the wall of the cage. Uh, but once it pressed that lever with its paw, then the door would open and the cat could escape, which is what it wanted. And so the idea here was that at first the cat has no idea what to do. It has no connection between a behavior and the desired result. But what Thorndike observed was once it exhibited that behavior once, it was much quicker at exhibiting that behavior again on future trials. So it learned the connection between the behavior, pressing the lever, and the door opening, getting out. And so this led Thorndike to develop what is called the law of effect. And that is the idea, really basically, that behaviors that lead to good things become more likely, and behaviors that lead to bad things become less likely. So Thorndike started this area of research And then B.F. Skinner, who we ran into in our first couple of lectures on psychology, developed the idea a little bit further, and he came up with the ideas of reinforcement and punishment. And here, reinforcement means any stimulus that makes the behavior more likely in the future. And punishment was any stimulus that makes the behavior less likely in the future. He also used the terms positive and negative. And we should be careful here because in our everyday language, positive and negative usually mean good and bad. But that's not the sense in which Skinner was using them. He was using positive and negative more in the sense of positive and negative numbers. So something positive was something you added. Something negative was something you took away. It had nothing to do with whether what you were adding or taking away was desirable, just whether you were adding or taking away. So this led to a variety of ways to affect future behavior. You can either add a stimulus or you can take it away, you can remove it. And doing so can either increase the likelihood of behavior or decrease it. So for example, if you add a stimulus and that stimulus increases the likelihood of the behavior, that was what Skinner called positive reinforcement. It's positive because you've added something, and it's reinforcement because it increases the likelihood of the behavior. And usually that reinforcement was something rewarding, like food or water. You can also have positive punishment, which sounds like an oxymoron, but isn't. So if you add something and it decreases the likelihood of the behavior in the future, that is positive punishment. For example, an electric shock. So if the animal, a dog or a mouse or whatever, exhibits a behavior and then is shocked afterwards, that's unpleasant. But it's something that's been added, and it's something that will decrease the likelihood of that behavior in the future. Similarly, negative reinforcement is where the stimulus is removed, but the likelihood of the behavior is increased. So if the animal, for example, is in a cage where the floor is shocking it all the time, that's unpleasant, and maybe the animal does some behavior that causes the shocking to stop. Well, that's something that's been removed. We've gotten rid of that stimulus of the shock. But whatever the animal did, it's likely to do that again because it wants to not be shocked anymore. It wants that stimulus removed. And so negative reinforcement is the taking away of something that causes the animal to increase the likelihood of that behavior. You can also have negative punishment. If you take away something and the animal has just exhibited a behavior and is less likely to exhibit that behavior again, that is negative punishment. And usually this is done by taking away something pleasant. So for example, you remove the food from the experimental chamber. You've taken something away, that stimulus is now gone, and the animal is less likely to do whatever it did right before that occurred. So those are the different combinations of negative and positive and reinforcement and punishment that we can have. So Skinner actually learned a great deal about reinforcement and punishment. And one of the things that he learned is the distinction between primary reinforcers and secondary reinforcers. Primary reinforcers are those things that actually satisfy biological needs. So things like food, water, shelter, sex. And of course, you'll notice that these are stimuli or events that have biological drives that correspond to them. Animals will automatically seek these things out. They don't need to learn to do so. Just like Pavlov's dog automatically salivated in response to the food. That's an innate biological response. It doesn't need to be learned or trained. And so Skinner used primary reinforcers in a lot of his research, especially in what's called a Skinner box, which is a chamber in which an animal can behave. It often has things like levers in it. And then a way of administering one of these primary reinforcers, either food pellets or water. And so then the animal would be more likely to exhibit the behavior again if it got food or water for doing so. And then there are secondary reinforcers. And these are stimuli that start off being neutral. So things like neutral cues, a light, or in Pavlov's case, a bell. There's nothing inherently biologically useful about a bell the way there is for food. A bell won't keep you alive. But the thing is that the bell became associated with the food, and things that become associated with food or for other primary rewards can themselves become rewarding, can become reinforcers. They're secondary because they are only reinforcers by virtue of their association with a primary reinforcer. Money, for humans, is a good secondary reinforcer. Now, there's nothing biologically useful about money. You can't eat it, you can't drink it. It's just little green rectangles. And so there's nothing inherently worthwhile about exerting effort in exchange for money. However, what money does is it becomes associated with the things that you actually need or want, especially those primary reinforcers. You can use money to buy food or to buy water, to buy shelter. And so money is a good secondary reinforcer. People in experiments will exert a lot of effort for money. And not just in experiments, people in life exert a lot of effort for money because it's reinforcing. It is a secondary reinforcer. Skinner also discovered that delaying a reinforcement or punishment actually makes it less effective. Uh, and this makes a certain sense if you think about it. So if an animal exhibits a behavior and is immediately reinforced for doing so, it's likely to associate that reinforcement with the behavior. It just happened. If you wait a while, seconds or minutes, then all these intervening things have occurred. The animals exhibit probably lots of behaviors. Maybe other stimuli have occurred. And so there are all these other things the animal could associate with the reinforcer if you wait that long. The same thing goes for punishment. That if you wait a long time before delivering the punishment, that it doesn't affect learning nearly as much as if the punishment is immediate. Again, because it's harder to make that connection between the reinforcement of the punishment and something that happened minutes ago. There are too many other possibilities. So immediate reinforcement and immediate punishment work best. Also, in general, reinforcements work better than punishments do. Reinforcements are more effective. Why? Uh, well, again, let's think about what the animal is going to do when it receives the reinforcement or the punishment. It's trying to associate that reinforcement or punishment uh, with a behavior and learn, change its behavior. Now, a reinforcement is going to increase the likelihood of the behavior the animal just exhibited. That's pretty obvious, especially if it's soon after the behavior. However, with a punishment, the animal is effectively being told what not to do, but isn't being instructed as to what to do. It doesn't know what behavior to exhibit. So a behavior might be less likely, but it's not nearly as effective as actually being reinforced for a behavior because, again, there are so many possibilities for what to do next. The animal may exhibit the same behavior it was just punished for. It may do something else that's not desirable because, again, if the animal is reinforced for a particular behavior, it can increase the likelihood of that particular behavior. If it's punished for a behavior, it doesn't know what to replace the behavior with. And so in general, reinforcements are more effective than punishments, and both things are more effective when they're delivered soon after the behavior of interest. So something else that Skinner discovered were what are called schedules of reinforcement. In other words, how the reinforcers are delivered matters. The contingency between behavior and reinforcement matters. And so there are several kinds of reinforcement schedule, and they're different in terms of their effectiveness. They're also different in terms of how easy they are to unlearn. The first kind are interval schedules. And here, interval refers to an amount of time. In a fixed interval schedule, the animal's first response after a set amount of time has elapsed will give them a reward. So, for example, if the mouse is in a Skinner box and gets a reward, gets a food pellet, the animal might then have to wait 2 minutes and then press the lever again, and then it gets another pellet. It can press the lever all it wants to before the 2 minutes is up, but it's not going to do anything. So the amount of effort, the amount of responses the animal makes are not the important part. It's the amount of time that is elapsed. So that's why it's called an interval schedule. And it's a fixed interval schedule because it is a fixed amount of time. It is always 2 minutes. And things like your weekend arrive on a fixed interval schedule. So you work for 5 days, then you get the weekend. The amount of time is what matters. You can't speed up the arrival of the weekend by working more. You just have to wait. And it's fixed because it occurs 5 days after the previous weekend. You can't change that either. And so it is on a fixed interval schedule. You can also have a variable interval schedule. So here the amount of time is still what matters, but it is not a fixed amount of time. It's not 2 minutes or 5 days for sure. Uh, there's an average amount of time that has to elapse. And so things like radio contests use this concept a lot. The variable interval schedule. They'll say that they're giving away tickets if you call in sometime between 3 and 5, or you have to wait for a certain song to play that's going to be played between noon and 6 p.m. So it doesn't matter how often you call, that's not going to affect anything. It's not the amount of effort you expend, it's the amount of time that's elapsed. But the amount is uncertain. You have a range, you have an average amount of time that you'll need to wait for. So that is a variable interval schedule. So you just have an average amount of time that has to be waited on before you can exhibit your response and get the reward, get reinforced. The other kind of schedule is called a ratio schedule. And these are where effort matters. It's not the amount of time, it's the number of responses that are made. So in a fixed ratio schedule, the person or the animal is rewarded for a certain number of responses, a certain number of behaviors. So in a Skinner box, a mouse might press the lever over and over again, and it gets a food pellet for every 10th press. It doesn't matter how long it takes to exhibit that 10th press. Maybe it does it within 10 seconds. Maybe it presses once a second. Maybe it takes 2 minutes to make all those presses. Either way, on that 10th press, it gets a reward. And for people, many people are paid in their jobs based on the number of products they produce, the number of items they sell. And so they are rewarded for every nth item or every nth behavior, where n is a known quantity. So every 10th shirt that gets made. Also, if you belong to some sort of a rewards club, or maybe you have a frequent customer card, those are usually on fixed ratio schedules. Once you buy your 9th sub sandwich, you get a 10th one free. It doesn't matter how long it takes you to buy those 9. It could take a week. It could take 10 months. But after you buy the 9th one, after you've exhibited the behavior 9 times, the 10th one is free. You get rewarded. That is a fixed ratio schedule. Finally, there's a variable ratio schedule. And this is where the reinforcement is related to your effort, your number of responses, but you don't know how many responses it's going to take. There's an average number of responses. And the classic example here are certain gambling games, like slot machines. So you don't know that that 10th lever pull is going to give you your payoff. It may be 5 pulls, it may be 100 pulls, you don't know. But again, it's also not the amount of time. You can't just wait for 2 days in front of a slot machine, pull the lever once, and expect to win. It matters how many times you pull the lever, but it is not a set number. And variable ratio schedules are notoriously hard to extinguish. All of these schedules of reinforcement can be extinguished, just like classical conditioning can be extinguished. But what Skinner found out was that while the conditioned stimulus and an unconditioned stimulus can be paired every time and then unpaired, and the animal will unlearn the association fairly quickly, when responses aren't rewarded every time, it may take a while to learn that association, but it also takes a lot longer to unlearn it. So especially for variable ratio schedules, you don't know how much effort you need to expend to get your reward. And so people are often willing to expend quite a lot of effort before giving up, before unlearning the association between the behavior and the reinforcement. So Skinner actually learned a few things in addition to the concepts of reinforcement and punishment. Uh, Remember that the B.F. Skinner is one of the most prominent figures in the school of thought called behaviorism. And behaviorism is concerned with the relationship between stimuli and responses. But especially when it comes to learning complex behaviors, the problem here is that an animal is unlikely to exhibit a complex behavior in the first place, which means it's unlikely to get rewarded for that complex behavior in the second place, and increase the likelihood of that behavior in the future. So how do we get complex behaviors? And the way Skinner did it was through what's called shaping. And shaping is a method by which you reward less complex behaviors at first, and then once those less complex behaviors are learned, you start reinforcing only more complex behaviors until you end up with the behavior you want. So, for example, if Skinner wanted a dog to enter the room and then jump on its hind legs, it's unlikely the dog would ever do that, even if it was behaving randomly. It's a very specific and unusual behavior to exhibit. So what Skinner did was reinforce the dog for, at first, simply entering the room and then going to a particular location. Once it was entering the room and going to that location, he would then only reward the dog for jumping of any sort. And then after a while, he would only reward the dog for jumping on its hind legs. So as each simpler step of the behavior was learned, the reinforcement was applied only to those more complex steps. Your book also gives an example of getting a pigeon to bowl a little ball into a set of miniature pins. Of course, that's not something the pigeon would ever do at first on its own, but at first Skinner just reinforced, rewarded the pigeon for facing the ball. Once it learned to do that, he rewarded the pigeon for rolling the ball. And once he did that, then he reinforced the pigeon for rolling the ball into the pins. And so a lot of complex behaviors on the part of animals are learned when animal trainers teach using this shaping technique. Skinner also observed superstitious behavior. So at one point he put pigeons in a Skinner box and then delivered food every fixed interval of time. It was a fixed interval schedule. And what he discovered after a while was the pigeons started exhibiting all sorts of bizarre behaviors that had nothing to do with food delivery. And the reason they did it is those behaviors were what they happened to be doing when the reinforcement arrived. Even though the behavior was unrelated to the reinforcement, they started exhibiting those behaviors all the time. Once they got reinforced once, those behaviors became more likely. And of course, once they were more likely, it was what the pigeons were probably doing when the second reinforcement arrived. Then they increased the behavior's likelihood again until pretty soon all the animals were doing were those behaviors. Until you get the idea of superstitious behavior. And we see this in humans for things like sports fans who will stop washing their clothes or wear a particular outfit or engage in particular practice in the hopes that their team will win. And they often do this because that's what they were doing when the team won once. And so they start connecting the two. Of course, the two are unrelated. I have a colleague who has performs monkey experiments, and he had one monkey who, anytime he exhibited the desired behavior, would also raise his hand. The hand raising had nothing to do with getting rewarded, and yet the monkey did it anyway because the first couple of times the monkey got reward for the behavior, it also happened to have its hand up, and so it started developing this superstition. And one thing we have to remember is that Skinner is coming from the school of thought of behaviorism. The idea that stimuli and responses are all that matter, that internal mental processes aren't important. And then along comes a scientist named Edward Tolman. And Tolman did some really interesting experiments that suggested maybe mental processes are important. We can't explain all of animal behavior with behaviorism. We certainly can't explain all of human behavior with behaviorism. So one phenomenon that pointed this out was what's called latent learning. And what Tolman did was he put mice in a maze and let them explore it. When they got to the end, they would be taken out of the maze. And he had a couple of groups of mice in this experiment. One group experienced exactly that. No reinforcement, no reward, just the maze. Another group was reinforced for solving the maze, for getting to the end. So the mice got food when they got to the end of the maze. Not surprisingly, the mice got much quicker at solving the maze when they were rewarded at the end. But there was a third group, and this is the important one. And the third group were allowed to explore the maze without reward at first, but then after a few days, Tolman started rewarding them for getting to the end of the maze. And after even just the first reward, the animals got much quicker at solving the maze. In fact, they were too quick to have learned that maze in just that trial where they got rewarded. Clearly, they were learning the whole time, and they only exhibited that change once they started getting rewarded for solving the maze. They only started solving it quickly when they got rewarded for solving it quickly. And so this pointed out the idea of latent learning, that the mice were learning the whole time even though they weren't being reinforced for it, and that you only saw a behavioral change when that reinforcement started happening. And this is something behaviorism couldn't explain by itself. Behaviorism would say they're not going to exhibit the behavior, they're not going to learn anything if they're not rewarded. And so they shouldn't have been learning anything during the first half of the experiment, but obviously they were. And so this was a big challenge to behaviorism. Another big challenge was the idea of cognitive maps. And for this experiment, Tolman gave the mice a simple maze at first, where all the mice had to do was run straight ahead into a tunnel, and then make a couple of turns, and they would get to a location where food was. And behaviorism would say what the mouse is learning is to go straight, make a couple of turns, get to the food. But then Tolman had a follow-up set up. So here, the mice can't run forward anymore. He's blocked that pathway. And the question is whether the mice will exhibit a behavior that gets them to the food, or whether they'll exhibit a behavior that's most similar to the behaviors they learned. In other words, is it the location of the food that matters, or is it the sequence of actions? And it turns out that the mice were actually learning the location of the food. If their original pathway was blocked, and there were many pathways as we see in this diagram here, they chose the one that led most directly to the food at the end of that arm. They weren't exhibiting the same behaviors, that sequence of left and right turns, but they were getting to the same end goal. And so what this pointed out is that the mice weren't necessarily learning a sequence of actions. They weren't learning the connection between specific behaviors and reward. They were learning that getting to a certain end goal, however you did that, would yield reward. So again, this is a more complex sort of cognition than behaviorism was interested in studying. The idea that you have a goal state, something you want to get to, rather than specific behaviors to exhibit. And this is a really important development, and it's one of the things that led to the decline of pure behaviorism and the rise of cognitive psychology. All right, so we have classical conditioning, we have operant conditioning. The question now is, how is the brain involved? How do these forms of learning depend on different parts of the brain? For classical conditioning, it depends on which form of conditioning is being used. So one famous kind is what's called eye blink conditioning. And for this form, the cerebellum is really important. So in this experiment, you have an animal, often a rabbit, for example, and the rabbit receives a puff of air in its eye. Now, that's the unconditioned stimulus, the puff of air, and it's unpleasant. And so the animal will blink, trying to protect its eye. That is the unconditioned response, the eye blink. So you can pair it with a neutral stimulus, like a light or a tone, and then the animal will blink in response to that neutral stimulus. Just like Pavlov's dog would salivate in response to its neutral stimulus, the bell. And so the cerebellum is critical for learning the connection between the neutral stimulus in the air path. For a particular kind of conditioning called fear conditioning, the amygdala is very important. And as we know from a previous lecture, the amygdala is part of the limbic system, and it's involved in emotional processing. So in fear conditioning, you have an animal, usually a rat or a mouse, in a cage, and you can play a tone, you play a sound in the cage. And the animal might respond to it, but it's not a fear response. However, if you then start pairing the sound with shocking the floor, that is, the animal receives an electric shock through its feet, now the animal starts exhibiting fear. It will start to do what's called freezing. It will stay in one place and not move. Its physiology will change. Its heart rate goes up, for example. Its blood pressure goes up as well. These are indicators of fear. And after a while, after the sound has been paired with the shock enough times, the animal will freeze and its heart rate will go up and its blood pressure will go up in response to the sound alone. So here the sound is the conditioned stimulus. The shock is the unconditioned stimulus. And the freezing behavior after the shock is the unconditioned response. Freezing behavior after the sound is the conditioned response. But the amygdala is critical for this. If you remove the amygdala from the brain of the mouse or the rat, it does not learn this connection. It will not exhibit that emotional response after the sound occurs. And so what we see here in this diagram in the bottom right is that conditioned response, which again is wiped out if the amygdala is removed. We also have operant conditioning, of course, and operant conditioning, again, is about learning the connection between behavior and outcome. And so what the animals are trying to do all the time, what we're all trying to do really, is predict what's going to happen based on our behavior, based on what we witness in the environment. And when it comes to predicting what's going to happen, the nucleus accumbens, which is part of the brain, it sits over near the basal ganglia, it's in the front. The nucleus accumbens is an important structure because it contains a lot of dopamine neurons. And dopamine is a neurotransmitter we've heard of in a previous lecture. And dopamine, at first, was thought to be the pleasure chemical. But now we know that it has more to do with learning than strictly speaking reward. And so what dopamine seems to do is indicate what are called prediction errors. And so if you're in your environment, you're behaving or even just viewing it passively, and you're trying to predict what's going to happen. Well, if something good happens and you didn't expect it, in this region of the brain, the nucleus accumbens, you get a burst of dopamine, which we see circled here. So this is a recording of the response of dopamine neurons. So every little dot is an action potential. It's a dopamine neuron firing. And so when a reward occurs, you see this bump, this increase in dopamine levels because something better than expected has happened. You don't see this bump if the animal expected the reward. Even if something good happens, if it was expected, you don't see this dopamine response. However, if you condition the animal either in an operant fashion or a classical fashion, now the animal starts to expect a reward after a certain stimulus or after a certain behavior. And now, if an unexpected stimulus occurs, or the animal exhibits behavior, you'll see an increase in dopamine release, shown by this spike. However, if the expected reward afterwards is not delivered, you actually see a decrease in dopaminergic firing. So what dopamine seems to encode is not the reward. If it encoded a reward, you would see a spike when the reward occurred, whether it was predicted or not. What you actually see is a change in dopamine levels based on whether predictions are satisfied or whether something surprising happens. And so we think the dopamine system is heavily involved in learning, and in particular, flagging when surprises occur, flagging when there's something that needs to be learned about in the environment or learned about with regard to behavior. Okay, that will do it for this lecture. Next time, we're going to learn about more complex forms of learning. So we'll talk about observational learning, which is learning not through our direct experience, but learning from the experiences of others, connecting their behavior to outcomes, and then applying it to our own life. We'll also learn about implicit learning, which is learning that happens under the radar, so to speak. We're often not aware of it. We're not aware that we're learning anything, and we're often not aware that our behavior is changing. I will also wrap up by talking about classroom learning, which is obviously relevant for a university course, but we'll understand what aids learning, what doesn't aid learning so much in that particular context. So that will be next time, and I will see you then.